Say, Charlie, how much heat does it take to make macaroni and cheese?
Well, Brent, I'm not sure, but you can use one of three equations to figure it out. Either Q equals ms delta T, Q equals m times the heat of vaporization, or Q equals m times the heat of fusion.
Teach me more. I want to know which equation to use.
Well, Brent, you use Q equals ms delta T when it's not undergoing a phase change. But if it's melting or freezing, you use Q equals m times the heat of fusion. And if it's boiling or condensing, you use Q equals m times the heat of vaporization.
That's fascinating, Charlie.
Isn't it?
What does the M stand for?
Well, the m in the equation is for the mass of the substance, the s is the specific heat, and delta T is the change in temperature that you get.
What's Q, Charlie?
Q is the heat change. It's what you asked me before.
Oh, okay. Cool. How do I know what the specific heat is, Charlie?
All you have to do is look on page 921 of your chemistry book.
Right there.
Yep.
Wow.
Hey, that fire's exothermic.
How do you know if it's endothermic or exothermic?
Well, first you have to find the potential energy, also known as enthalpy, of the products and reactants. If the reactants have more enthalpy than the products, then it's exothermic. But if the products have more enthalpy than the reactants, then it is endothermic.
Seems easy enough.
Yeah.
Thanks.
Thanks, Charlie. So, Charlie, some of my friends were talking about spontaneous reactions. What is that?
Well, some reactions occur without having any catalyst to make them go. It all depends on the amount of entropy or disorder within them.
What's that mean?
Well, if there's a high amount of entropy, then it is more likely to be spontaneous. But if there's a low amount of entropy, it's not spontaneous.
Maybe you should show me an example.
Oh, I will.
Oh, wow.
If this room were a reaction, it would definitely be spontaneous because of all the disorder or entropy. There's a very high amount of entropy.
Lots of disorder. I get it.
Yep.
Makes sense.
It's spontaneous.
Awesome.
If this room were a reaction, it would definitely not be spontaneous because there's no disorder or entropy.
Right. It's perfectly plain.
That is correct.
It all makes sense now. So, Charlie, is there any way to speed up a reaction?
Heck yes.
How?
You just have to use a catalyst.
A catalyst?
Yeah, it's something that you add to the reaction to speed up the reaction. Like this paintball, for example. If it were to hit a person, it would make them speed up whatever they're doing at the moment.
Yeah, it would.
So this can be a catalyst.
Oh. Oh! Ah!
Start running. Run. Run.
Run. Thanks, Charlie, for teaching us all about chemistry. Now I know so much more about endothermic and exothermic and entropy and
Catalyst.
enthalpy and real life situations.
A lot more.
It really helped in life.
You taught us so much. You're welcome.
I don't know what I'd ever do without you, Charlie.
This is getting creepy.
So, Charlie, some of my friends were talking about spontaneous reactions. What are those?
Well, some reactions happen without any catalyst.
What's a catalyst?
I wasn't planning on explaining that. Like, God.
What the? Wait, I can see it! It's right there!
That better not be in our video.
Okay.
No,
Harley.
no.
What kind of reaction was that?
Are you filming this, Eric? I can't turn. There's a car coming.
I've thrown many a roll of toilet paper in
Oh,
that
you
tree.
have, haven't you? Wait, okay.
Well, your one foot isn't even on it. It's like it's kind of dangling there.
Wait a sec.
Front foot first. Or back foot. Okay.
Can't do it.
Why don't you try like up on the hill and coming down?
Stop
No, that's
filming
not
me.
hard.
So Charlie, is there any way to speed up a reaction?
Well, yeah.
How?
Wait, stop.
It's right there. Come on. No,
Can do it.
Seriously, can't get it.
you can. Are you videotaping?
Yeah.
Come on. Almost. You got it.
This is not coming off of me.
Yes, it is.
Oh my god.
Yeah, see, look, right there.
It's tighter than tight.
It's okay.
Put the gloves on. Knuckles hurt. Put your arms down.
God!
Perfect.
Wait, isn't he running?
Are
Not
you
yet.
filming, Emily?
Yep.
Run!
Oh!
Oh! Ah!
Start running. Run. Run. Run.
Run.
God, that sucks.
Safety on.
Blood. Dry blood.
Ouch. Eric. Did I even hit you? Yeah. In the